In this video, we're going to continue our discussion of statistics by talking about measures of central tendency. So imagine taking your data, collecting your data, maybe you've organized it in terms of a table or in some type of graphical format. Well, once our data is accumulated and organized, now we need to actually answer questions about it. So what are we seeing from the data? In a lot of cases, we're interested in what we would consider a typical value or a common value for our data set. What that means in terms of what we mean by typical, what we mean by common, depends on the situation we're in. But we can use measures of what we call central tendency because we're talking about sort of the center of the data distribution, the center of where all the data is collected. Think about data being clustered. We can use this to describe what we mean by typical in a few different ways. So we have 4 different measures of central tendency that can be used to sort of describe how the data is clustered, and again, what we're going to think of as typical, just depending on what we're interested in. So the most common one, the one you're probably most familiar with, is what we call the mean. Another word for mean is average. So if you've ever averaged a bunch of values, you've determined what you call the mean. So if we want to take the arithmetic average of the data set, that's going to be the mean of the data set. Another measure of central tendency that tells us what sort of typical looks like for our data set is what we call the median. So the median is going to be the middle element when the items are ordered from smallest to largest. So I remember median, think about like the median between 2 directions on the street. So the median is going to be what's in the middle. It's going to be the halfway point between one side of the street and the other side of the street. Another measure of central tendency is called the mode. So the mode is going to be the data item that appears most often. If you have repetitive data, you have data points that are repeated throughout your collection, then the mode may be valuable to say this is going to be the most common element individually. And then the last option is going to be the mid-range. So mid-range is another thing that's kind of like halfway point, kind of like median. The mid-range is going to be the sum of the highest and lowest items, and then we're going to divide it by 2. So it's just another way of describing the middle of the data set, like the median. So notice they all start with the letter M. Remembering which one is which is going to take a little bit of work. Try to think of ways to remember what each one represents, maybe using some type of comparison. So range, that means how far we go across. Range means how far we go across from smallest to largest. The range of values is the spread in a sense. And so mid means halfway. Well, half means divide by 2. So mid-range means take the spread and then divide it by 2. Mean is the only one I don't really have a good way to remember, but if you can remember all of the other 3, median means in the middle element. Mode rhymes with most, so mode means the element that occurs most often, and mid-range means the range. Mid, in other words, divide by 2. If you can remember what those 3 are, then just remember that the mean is the average. So let's just look at some raw data sets, unorganized data, and let's find our different measures of central tendency for our data. So to find the mean, what does that look like? We're just taking an average. Well, how do you take an average? You're going to add up all of the data items and then divide by the number of items you see. So what does that look like in terms of a formula? Well, the symbol we're going to use for mean is going to be X with a bar over it. So that means we're taking the data set, and the bar over it means we're taking the mean. It's going to be the sum of the values. So this particular symbol, this is the capital Greek letter sigma. This is a symbol used in mathematics to tell us to add up things. So you see that symbol, that means take a big sum. It means add up a bunch of things. What you're adding up are the data values, which are represented by that variable X. So it's saying add up all the data values and then divide by the number of items, which we're going to call N. You don't have to memorize necessarily a particular formula if you understand the procedure for what we're going to do in this case. This is just a formulaic way to represent it. So add up all the data items, divide by how many items there are, and that's going to give you the mean of the data set. Now to find the median, you're going to have to start by ordering the data items smallest to largest. Now, if there are an odd number of items, then there is a true central item. There are items smaller than it, there are items larger than it, and it's the true center. So that true center, that element in the middle, is going to be the median. It's going to be the middle term. Now, if there are an even number of items, then that means you could break the data set into two pieces, but there's no element that's actually in the middle. There would be two elements clustered in the middle. Well, if that's the case, then you're going to take the average of the two middle items. So the one that's to the left of the true middle, the one that's to the right of the true middle, you're going to take those and average them. In other words, add those two values up and divide them by 2. That's going to be what we think of as the median. So the median won't necessarily be a data point in the set, but it's going to be the average of those two middle data points centered around that true middle. Now, if we want to know exactly where the median is going to occur, if there are n data items, then the location of the median will always be n plus 1 divided by 2. That'll tell us the location. So if we have a long list and we want to know where the middle is, maybe it's not a list in a line, maybe it's a list in a few lines, and it's hard to determine the true middle. If you can take n plus 1 and divide it by 2, that's going to tell you the location. Now, of course, that is dependent upon us already having our list of data points in order. We always have to start there. But once it's ordered, we can use that to determine the location of our median. Now, mode is typically going to be the easiest. You just want to identify the most common item. Now, if there's no repetition, if no data point is repeated, then there is no mode. Now, what if there are repeated data items, but maybe different data items are repeated the same number of times? Maybe 2 different data items are repeated 5 times, and those are the ones you see most often. Well, in that case, the 2 different data items that are repeated would both be considered a mode. So it's possible to have more than one, or it's possible to have no mode at all if there's no repetition in your data set. And then for the mid-range, again, it's defined as the range, in other words, highest to lowest. It's the range of values, the length from highest to lowest, and then mid just means divide by 2. So that's going to be how we find our mid-range. So let's look at a couple of examples. We want to find the mean, median, mode, and mid-range. Try to say that 10 times fast for each of the following data sets. And notice they're not organized in any particular way, but we want to find each of these values. Okay, so we have, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9 values in our data set. That's going to be important to know. So for anything involving n is going to be 9. That's going to be the number of elements in our data set. Now the mean of this data set is just the average. So we're going to add up all the values in the data set. We know there's 9 elements, so we're then going to divide by 9. So how would you do this in the calculator? Well, I would do it in 2 steps. I would start by adding up all of the actual data points. Of course, be careful as you go. Make sure you check what you're typing as you go. Even one mistyped element will change the answer for the mean. So add all of those up, get that as a subtotal, and then divide by the total number of elements, which in this case is going to be 9. So we have 53 plus 13 plus 34 plus 41 plus 26 plus 61 plus 34 plus 14 plus 69. It's going to be important to count. One easy thing to do is to miss a particular element. So I'm going to scroll back over to the very beginning, and I want to count, and I want to make sure I have 9 elements here. So 53, there's 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So we do in fact have 9 elements, and they're the elements represented in this data set. So that's going to be the numerator for my mean calculation. It's the sum of all of the data elements. So I'm going to hit enter, and that gives me a total of 345. I'm then dividing that by how many elements there were in the set, which in this case is 9. So divide by 9, and that's going to give us our mean. Notice we've got a repeating decimal. The symbol we can use to indicate that is going to be this bar. So once you establish a pattern with your decimal points, you can put a bar over the last one, and that's going to tell you repeating in the same fashion indefinitely. So that's going to be our arithmetic mean. Now, what about the median? Remember, median is the true midway point. We know there is a true median in this particular data set because there's an odd number of data elements. I need to start by listing them smallest to largest. So I have to start by ordering them before I can do anything else. So first thing you need to do is find the smallest element. Well, in this case, the smallest element is going to be 13. So 13 is the smallest. From there, I have 14. And then I have 26, I have 34 and 34, I have 41, I have 53, I have 61, and then I have 69. So make a list as you go. How do you know you finished the whole list? Well, remember there should be 9 in the original list, so the rearranged list, which is still the same set of data, should also have 9 elements in it. So of course, double check that once you've ordered your list. What you can also do, if you have this on your own sheet of paper, is cross off items as you use them. So once you use the 13, cross it off. Once you use the 14, cross it off. That's going to keep you from overusing an item or maybe from skipping an item. So cross them off and then use that to make the list. Now, because there's 9 elements in this list, there is a true center. So the 5th element has 4 on either side of it. So it's going to be the true center. Now remember, for the positioning, in terms of determining the position of the median, we have a formula for that. If we take our value for n, which is 9, and add 1 to it, we get 10, and then divide that by 2. That's going to tell us the location of the median. In this case, it's going to be the 5th element in the list, which in this case is 34. So 34 is our median. It's going to be the true halfway point in this data set. Now the mode is just the item that appears most often. Finding the median is also going to help you find the mode. The mode may be difficult to find if your data is unorganized, because then finding repeated values is going to be more difficult. If you've already taken your data and you've organized it smallest to largest, then it's going to be easy to spot repeating values. In this case, 34 is the only data point that actually repeats. It repeats 2 times. So that means 34 is going to be the mode in this data set. Now, what if none of the elements repeated? If none of the elements repeated, then that means we would say there is no mode. What if there were 2 34s and there were also 2 41s, for instance? Well, in that case, because both of those values repeated the same number of times, 34 would be a mode and 41 would be a mode. So either there's a single mode, which it was in this case, or there might be none at all, or there might be more than one mode if you have multiple repeating values. It just depends on your particular data set. And then our mid-range is going to be the sum of the lowest and highest values, and then we're going to divide it by 2, which is essentially going to give us a sense of center in a different way. So 13 plus 69, lowest element to highest. Notice that getting the median gives us 2 other values that are easier to calculate once we have that median, once we know what's truly lowest and what's highest. So 13 plus 69, and then we're going to divide that by 2. And that's going to give us the mid-range. So the mid-range is going to be 41. Notice it's an actual value in the data set, but that won't always be the case. If you sum up these 2 values and divide by 2, it's very possible that you'll get a value that is not represented in the data set. It just depends on the values you have. It depends on the values that you're adding up, whether or not dividing by 2 gives you something that's actually whole number, or if it gives you a fraction at that point. It just depends on the situation. Okay, let's look at another example. So we have a new data set. Let's start by counting the number of elements. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this case. So we know n is going to be 10 each time we have to use that value. So for our mean, we're going to take all of our elements and add them up. We know there's 10 of them, so we're then going to divide by 10. So I recommend take a minute, pause the video, make sure you can do that, make sure you can get the mean. So I demonstrated how to do it for the first example. Make sure you can do it yourself for this example. So add up your data points. There's 10 of them, so divide by 10. So pause it and see if you can do that. And once you do that, you should get 21.9. In this case, there is no repeating decimal. There is truly a terminating decimal, and we're not going to round. With problems like this, we're going to avoid rounding. So in this case, our median is going to be our mean is going to be 21.9. Okay, now what about the median? Well, we need to start by rearranging all of our data elements, smallest to largest. And again, you might think of just checking them off as you go. So the lowest is 5, but notice we have 5 3 times in our list. We have a 2 16s, okay? We have a 29, but there's also a 28, so 28 and then 29. And then we have 32, we have 35, and we have 48. So listed smallest to largest, that's going to be our data set. Now, why is it not necessarily a bad thing to check them off? Well, you check them off to go and you cross them all out, but now you just have a new version of the data set. So you still have a data set to work with, you just have a rearranged version of it to work with. Now here we're looking for the median, so we're looking for the halfway point. This situation is different from the one above because we have a different number of data elements. So the one above, we had 9. 9 has a true center, so 5 is the number around which we would have the same number of elements clustered. So 5, the 5th location, would be the actual true center of this collection of data. This current example is a little bit different because we have 10 data points. Well, 10 can be divided in half. You divide 10 in half and you get 5, but the 5th element and then or let's say right there around the 2, you have to collect, or you have to go in the middle in order to determine what the actual true center is going to be, because you divide it in half, you get 5, so there's 5 elements to one side, 5 elements to the other side. There is no true center, okay? So the central element we have to determine from the other 2 that are then clustered in the center. So we're going to take the average of those 2 there in the center, which are going to be 16 and 28. So add up 16 and 28, divide by 2, and that's going to give you 22. Now, how does the positioning kind of thing work in this situation? Well, remember we said we were going to take the number of elements in the set, which in this case is going to be 10. We're going to add up 1, and then we're going to divide it by 2. Well, that gives us a fractional position. It says the 5.5 position. Well, we don't have a true 5.5 position, so we have 1, 2, 3, 4, 5, and then we would jump to the 6th position. What this is telling us, though, is that we want the halfway point between 5 and 6. So 5.5 means go to the 5th position, and we want whatever value would be halfway between position 5 and position 6, which in this case is represented by the value 22. That's going to be the halfway value between 16 and 28. So this formula with positioning still works, you just have to interpret it in a slightly different way. Okay, now what about the mode? What appears most often? Well, in this particular data set, we have 2 values that repeat. So 5 repeats and 16 also repeats. The mode is going to be the one that repeats most often, though. So 5 repeats 3 times, whereas 16 only repeats 2 times. So in this case, the most common value is going to be the value 5. So our mode is going to be 5. And then last but not least, our mid-range. We're going to take our lowest value, add it to our highest value, and then divide the 2. So think of averaging. Essentially what we're doing is we're averaging lowest and highest value. Anytime we take 2 things, add them up and divide by 2, that's going to be an average. But in this case, we're averaging the lowest and the highest values. We add those up, divide by 2, and we get 26.5. So 26.5 is going to be our mid-range. So we've looked at a couple examples where we just have raw, unorganized data. We do have to organize the data a little bit in order to be able to calculate the median, but in general, we can find all of these measures without too much organization needed. Now, what if our data has already been organized? So what if we have a frequency distribution of our data? We don't want to go backwards and look at raw data. A frequency distribution is going to be helpful, but how do we use the frequency distribution to find all of these values? What's the difference here? Well, the difference is we don't actually have just a strict list. We don't have a list of values. If we have the frequency distribution, the list is implied, but the list has then been condensed down and organized in a different way. So we can still find all of these measures of central tendency. We just have to think a little bit more closely about what the distribution is telling us. So to find our mean, remember, we're taking all of the data elements, we're adding them up, and we're dividing them by how many data elements we have. So to find our mean, the way we're going to do that based on having a frequency distribution is we're going to multiply each data item by its frequency. What does that mean? Well, let's preview this example really quick. We know that the data element 30 occurs with a frequency of 3. So if we had a list of all of the data elements described by this table, we would see 30 3 times. So we would take 30 and we would add 30 plus 30 plus 30. Well, another way of saying that is take 30 and multiply it by 3. So the component where we'd add up individual data items, we can actually do just by multiplying the data item by how often we see it. That generates the same value, but it uses multiplication instead of using addition. So we're going to do that for every data element and its frequency. We're going to multiply each data item by its frequency, add up all of these products, which is then going to give us that total sum of all of those data items, and then divide by the total frequency. That's going to be the number of items. So as we take the frequency in total tells us how many data items were in the set. We just have them grouped in a specific way, and we have those individual frequencies, but all those frequencies then sum up to give us the total number of elements that were in that original raw unorganized list. So that's going to be our frequency distribution mean. If we want to represent this algebraically, we're taking the sum of each data element multiplied by its frequency. So X represents a data element, F represents frequency. Again, this is the Greek capital letter sigma, which just says take the sum of all the things that look like this. So every data element times its frequency, and then take the sum of all of those, and then divide by the total number of elements in that list that's then been organized, which is represented by the sum of those frequencies. That's going to be our mean. So it's the same thing algebraically, we just have to look a little bit more closer at our table to understand how we get the same information to find this kind of measure of central tendency. Now, to find the median, one thing that's nice about a frequency distribution is we already are organized. We're already organized smallest to largest based on how that frequency distribution is formed. But we don't have an actual list of values to say this is the center or these are the two center elements. The frequency distribution does tell us this, but we have to work a little bit harder to find it. In this case, we're going to have to use that position formula where we take the number of elements, add 1, and divide by 2. This is going to tell us what the location is for our center. So we count by frequency. The frequency tells us, well, this is going to be the first, second, and third place. This is going to be the 4th, 5th, 6th, and 7th, because we go from a frequency to 3 through to a frequency for 4. Once we go to the correct location, the data item associated with that location is going to represent our median. Mode is going to be easy to spot based on our frequencies. Whatever the most frequent element is, that's going to be our mode, which we can immediately see from our frequency table. And then finding the mid-range is not going to change. So lowest element, highest element, add them up, divide by 2. Okay, so let's look at the actual values and let's actually go through and find all 4 of our measures of central tendency. So we have particular values representative of some type of score. We either get a score of 30, 33, 40, or 50. Those are the individual values from this data set. And we already know the frequency at which each value occurs. So rather than taking this and then rewriting it as an actual list of data elements, we just have to infer what we can from the table and from the information we already have. So 30 occurs 3 times. If we were going to find the mean from a raw data set, we'd have 30 in our list 3 times. So we would be added up 30 plus 30 plus 30. We can take 30 and multiply it by its frequency, and that does the same thing. So 30 times 3 is going to give us 90. Same thing for the other 3 elements in the set. So 33 times 4 is going to give us 132. 40 times 4 is going to give us 160. And then 50 times 1 is going to give us 50. So those are all the little subtotals. Those are the results of taking individual matching items and adding them up the number of times we see them. Well, then we need to take those subtotals and add those up. And that's going to give us that numerator for our mean. Well, now we need to take that sum and we need to divide it by how many elements there were in this particular data set. That can be determined from the frequencies. So the first element had a frequency of 3, the second had a frequency of 4, the third had a frequency of 4, and then the final one had a frequency of 1. So 3 plus 4 plus 4 plus 1 is going to give us a total of 12. So that means if there were a list of all of our data elements, there's going to be 12 elements in the list. So we're going to take the sum of all of those subtotals and we're going to divide it by the total number of elements represented in this set by this frequency distribution. So that's going to be a division by 12. That's going to give us a mean of 36. So 36 is the true average of this particular set of data represented in this table. Now, what about the median? Well, we don't have the list, so we can't determine the halfway point from a list, but we can determine the position for the halfway point. We're going to take the value for n, the total number of elements in our set. We're going to add 1. So take 12, add 1, and then we're going to divide that by 2. And that tells us that the median is going to be in the 6.5 location. So halfway between the 6th element and the 7th element. Well, we need to determine what that element would be. So remember, if we were going to do the median from raw data, we'd organize all of the elements in ascending order, and then we'd find either the halfway element or the 2 halfway elements and then average those. We can make that determination from the frequency distribution. We just have to understand what we're looking at. So all of the elements have already been organized smallest to largest just based on the data points being organized smallest to largest. We just know how often those data points would have occurred. Well, we want whatever's at the 6.5 location. Well, the first 3 elements in the list would have been 30. So positions 1, 2, and 3 would be represented by the number 30. We want to get to the 6.5 locations, so whatever would be halfway between 6 and 7. So 1, 2, and 3 would be represented here, and then 4, 5, 6, and 7, the next 4 elements, would be represented as 33. Well, we want the element at the location 6.5. Well, both the 6th element and the 7th element are represented by this data point. So the 6th element is 33, and the 7th element is also 33. Well, what's halfway between 33 and 33? Well, there is no real halfway point. In this case, the element we would want would be 33. So if the 6th and 7th element are going to be the same, then that means our median is going to be whatever that value is, which in this case is going to be 33. So I hope that makes sense how we get to the actual location we want. We use these frequencies to count the locations. So 1st, 2nd, and 3rd point in the list, and then 4th, 5th, 6th, and 7th location, the next 4 places. So this would then give us the 8th, 9th, 10th, and 11th position, and then the 12th position. So the frequencies not only tell us how often we see these values, but based on how the table is organized, they also tell us what the ordering is and which elements occur in which position. Okay, now what about the mode? The mode is going to be the element that occurs most frequently. Keyword frequently, think frequency. We're looking at the frequencies. Well, 33 has a frequency of 4, but 40 also has a frequency of 4. Those are the most common elements, but they occur with the same frequency. So that means both of these values are going to be modes for this data set. So we actually have two separate modes. 33 is a mode, and then 40 is also a mode. And then as with our raw data set, the mid-range is just going to be the sum of the lowest and highest element divided by 2. So it's the average of the lowest and the highest. Another way of describing sort of halfway. So in this case, that's going to be the element 40. Notice that is truly the halfway point between 30 and 50. If you think of what's halfway between 30 and 50, well, the number that's halfway is going to be 40. So that's going to be the halfway point between our maximum and our minimum. Okay, let's look at one more example. Students in an introductory statistics course were surveyed during the first week of the course. One question asked, how stressed have you been in the last 2 weeks on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible? The following frequency distribution shows the students' responses. Okay, so our values for X, our actual data points, our data values, are the values along that scale from 0 to 10 that students were allowed to choose as their answer. And then the frequency at which those answers were seen is listed below. So 0, meaning I'm not stressed at all, occurred with a frequency of 2. 10 being I'm as stressed as I could possibly be was represented at 14, a frequency of 14. So let's start by determining how many elements there are in the list, because notice it doesn't say how many students were surveyed. That can be determined from those frequencies. So the total number in that list of frequencies tells us how many data points there were. So just to verify, we have 2 plus 1 plus 3 plus 12 plus 16 plus 18 plus 13 plus 31, let's see, okay, 31 plus 26 plus 15 plus 14, and that sums up to 151. So 151 people were surveyed. We know we're going to need that value for a couple different things. We need it for the mean, we need it to determine the location of the median. That value is important. Okay. So first thing we want is going to be our mean. What is the true average of this particular set? Well, remember the frequency distribution represents, in this case, a list of 151 data points, but they've been organized. They've been listed smallest to largest, and we know how often individual values repeat. So 0 appears twice. So as part of the mean, we'd be taking 0 and adding 0 plus 0. 1 occurs once, so we'd be taking 1 and only adding it on once. 2 occurs 3 times, so we'd be taking 2 plus 2 plus 2. 3 occurs 12 times, so we'd be adding on 3 12 times, and so on and so forth. So we can simplify that by multiplying each data point by its frequency. So pause the video for a second and do that. You want to take each data point, multiply it by its frequency, which is going to give you a subtotal towards your mean. So see if you can do that. Now, once you've done that, you then want to add up all of those subtotals. So within each of those individual parts of the sum, you want to sum up those subtotals. And then we're going to divide by the total number of elements in this data set, which we know to be 151. And once we do that division, we get 6.46. Notice this makes sense just based on how this data looks. So the data ranges from 0 to 10, and then about 6.5, which would be between 6 and 7. It makes sense that that would be potentially a value for the average. We've got about halfway represented in either way. So this would be the central value around which all of our data is clustered. That's going to be our mean. Now, if you were to get a mean of something greater than 10, it means your answer does not make sense. If you get a mean greater than 10, that's saying the average answer was greater than 10. Well, if the highest answer you could answer based on the scale is 10, then having an average of greater than 10 doesn't make any sense. How might you end up with something like that? Well, one mistake you might make, if you were to take these individual subtotals and add them up like you're supposed to, but you look at this and you say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. And maybe you take the sum and you divide by 11 instead of 151, which would be an easy mistake to make just looking at all these numbers. There's 11 numbers right here, right? Well, remember, those numbers are representative of products we got from multiplying a data point by how many times that data point was seen. So we're really adding up 151 data points. We just end up with 11 subtotals towards our larger total. If you were to make that mistake, then that would potentially be a way you might end up with a mean greater than 10. So it's important to think with these values, what do these actually mean? These are central measures. So these are describing how the data is clustered, what sort of values are most frequent, and again, what do we think of as being sort of a typical value representing this set in the particular way we're describing typical. So just keep those kinds of things in mind. Now, what about the median? Well, remember, we don't have the actual list of data. We have an organized frequency distribution of the list. So we can determine the location of the median. So we're going to take our value for n, which is 151. We're going to add 1 to it, and then we're going to divide by 2, which gives us 76. So that says we're in the 76th position in order to find the median. So we're going to use the frequencies to count what position would be the 76th and what data point it's associated with. So 2 plus 1, that takes us all the way to the 3rd position, plus another 3, well, that's going to take us to the 6th position, plus 12 is 18. Let's see, 18 plus 16, that's going to take us up to the 34th position, plus 18 is going to take us up to the 52nd position, plus 13 is going to take us to the 65th position, and then plus 31 will take us to the 96th position. So once we get up to the number 6, that takes us to position 65, and then once we get through everything represented by 7, we're at position 96. So if we want the 76th position, that's going to occur somewhere within the range for 7. So 6 takes us to a position too low, and once we finish all the 7s, we're to a position too high. So that means the position we want is associated with the value 7. So our median is going to be 7 in this case. Now 7, notice it's also going to be the mode. It's the number with the highest frequency. So because it has the highest frequency, the true highest frequency, it's going to be the mode. And then our mid-range, our halfway point, you may not even have to do this algebraically. Your lowest number is 0, your highest number is 10. Well, what's halfway between 0 and 10? In this case, it's going to be 5. So 5 is going to be our mid-range. So that gives you a taste of what this looks like in terms of determining what's typical for a data set, what's central for a data set. There's different ways of describing what typical means depending on the type of information we're interested in. One of these measures versus another might be more valuable. Now keep in mind, this is based on data that's numeric. So if we were talking about data that's not numeric, maybe our data is represented by last names, something like that, then we couldn't use mean, median, mode, and mid-range the same way we do here. We might have to take our data and convert it to something numeric. So maybe a way to convert it would be to determine how many last names started with a particular letter. So maybe you have 5 last names starting with the letter A. Well, in place of those 5 data points, you might say that A has a frequency of 5, something like that. In those situations, maybe you can convert your data to something numeric, but just keep in mind all of these measures are based on data that is numeric, not data that's non-numeric, data that's somehow otherwise descriptive. But these are going to be good options if we want to describe what we see as commonalities among the data values in our set.